Welcome to the Guardian Group podcast series. The Guardian Group, providing extraordinary solutions to today's exceptional problems.
Hello, podcast fans. Welcome to another edition of the Guardian Group podcast series. Today, we're going to talk about microelectronics, nanoelectronics, and how the industry is moving forward. Again, I'm joined by my colleague Rick Marat from Toronto, Canada. How you doing, Rick?
Not bad, Todd. It's a very nice fall day here in Toronto. The leaves are changing color. It's a beautiful time of year to see all the different colors and nice little breeze and the sun bringing you warmth. It's just like our industry. It's an exciting time.
Absolutely. Same thing here. Weather's good for another day or so. So we're going to talk about microelectronics. That seems to be a buzzword nowadays where the industry is moving. For me and Rick, we go back to when the Great Pyramids were being built, when we had macroelectronics. And what I mean by that is when we were all dealing with pin and hole type technology, when all SIPs and SIMs and resistors, capacitors were all wires, all went into pin and hole, gigantic boards. I'm sure you remember all that, Rick.
That's so true, Todd. Who would have thought of they create something called a SMT or surface mount pad? Back then, it was all component leads that went into holes in these gigantic boards with gigantic electrical testers. Sometimes we had comparison tests. Sometimes we were just on the brink of bringing in something called a netlist test. It was interesting then, but even more interesting now.
Oh, absolutely. I like you mentioned that. I go back into the mid to late 80s when I remember seeing surface mount technology the first time, when back then we were taking just basically diazo films and digitizing them on a table to create drill files for the pin and hole technology. And then all of a sudden this one group, who I won't name, but they make a lot of electrical meters, but all of a sudden their films came in with these little rectangle pads and square pads that didn't match up on both sides. And like, what is this? And that was surface mount. So that was the beginning, and big testers, 100 mil grids and all that. And then we got into what we called micro, is when we started seeing the SMT technology and SIP technology packages going into 50 mil centers. And we thought that was tough back then. And now it's even, gone a lot farther than that. So,
Todd, what always amazes me is that even when we change from through-hole technology into surface mount into microelectronics, the industry seems to find a solution across the board. The industry is very resilient. It finds solutions, and it comes up with solutions across the board. It's very interesting, especially with our history. I'm very excited to figure out what the solution is for microelectronics.
Oh, absolutely. Today's, implementation that we see on a daily basis, which augments the microelectronics world, as we're seeing, the blind and buried vias, which have been around for a long time, but we're seeing now the via in pad with the HDI stuff, and we have buried passives now that include inductors and capacitors and resistors, which have been around for a long time, but we're now seeing capacitance actually buried in there, and even inductance, which I think is pretty exciting myself. And then with all this via and pad technology, the sequential laminations with the blind and bury microvias, I mean, it's pretty amazing.
So even they talk about HDI, now there are even buzzwords out there, ultra HDI.
And I'm still getting my hands around, or my head around, HDI and the microns, So, I mean, we're talking about some challenges that we're facing out there today. Manufacturing, the big thing is line and space challenges for the new component footprints and things like that. Material challenges for high-speed signal transmissions, tighter requirements, supply chain issues. I mean, we really got into that, not necessarily because of the HDI and microelectronics, but that COVID thing put a pretty good stop in the supply chain, which is starting to recover. And then, of course, we all know, the loss of market share when a lot of outsourcing or offshoring happened. And, maybe, Rick, you can talk a little bit about how the whole onshoring and offshoring switcheroo is kind of happening and kind of how that makes a challenge for us here in the North Americas and Europe.
Well, we all know, Todd, in early 2000s, as you mentioned, we had a lot of, even North America here, we had 12, 1,300 board shops in around that range, and we're down just to a small handful of board shops. And it's been a big change. And in Asia, especially in Taiwan, they grew, they adopted to the smaller technology, the micro, the HDI very quickly throughout some growing pains, but they managed to produce this stuff in high volume at low cost.
They sure have.
And
I mean, you just take the iPhone, for example. I mean, that's just one of many, examples.
yeah, we can't even build that on the well, we could build small prototype stuff in the on the US soil, but there again, nothing in volume.
Right.
And some of the chips, because they're working on fixing this, but some of the chips you can't even do the technology here in North America or Europe. It's all in Asia, right?
Right.
But we see some of this, some of the lobbying the governments does pay off. You see some of this starting to come back. With the fab shops moving here, some big spending on the government sides, all levels of government. Like if we talk North America, the U.S. government leading the way, of course, and then a little bit from Canadian and the European Union is starting to have a chip act as well. We all need this technology, but along with this technology, we need somewhere to put the chips. Chips, as they say, they don't float. They have to go on something, some sort of connection device.
Right. Right. I mean, I definitely like you see the American soil, but yeah, I don't want to discount the advances and contributions of the Canadian and Europe markets. Without them, we wouldn't have a consortium to try to push where we're trying to get on sourcing and such. An electrical test here in the North Americas, I mean, I'm going to be the first to admit, as far as testing some of this stuff that's over in Asia, we're far behind. Our older equipment struggle with these kind of designs without coming up with really, I would say, creative solutions. We have flying probe challenges because over here, flying probe is not necessarily your best solution for high volume, the kind of commercial volume that we're talking about. And then, educating customers is a big thing that you and I talk about a lot on the requirements and what test options are available and even allowed, for certain types of product.
Yeah, that's correct, Todd. That's correct. Yeah, I know that in Asia they have still used. You and I remember back when in the 80s and the 90s we started building fixtures. We did something called wire wrap. We
Oh,
wire wrapped.
absolutely. That was the term. A lot of people use the term clamshell or, wire wrap fixtures because all we had was single-sided grids at 100 mil. And, doing a double-sided board now with SMT on both sides, yeah, you had to do a lot of wiring. And that here over here, except for functional fixtures and such, which is a different story, um, that art is kind of lost here to specialty shops like our guy Steven there in Denver.
When you travel to Asia, you see many shops have dedicated fixtures. Yeah, there's some different technologies out there where they use a spring, some sort of contact spring with a wire on the end of it that does the connection with you put a test pin on top of it. Sometimes you just have a receptacle where you put the test pin in. Sometimes you just kind of bond to the bottom of the pin because you're going down 20 microns.
Yeah, you're going. Go ahead.
The technology is there, and now they're flirting around with 50 micron fixtures. I don't know how they're ever going to get that to work, Todd, but that stuff is in Asia. It's not in North America or Europe yet, but it could be.
Yeah, I mean, it's technology's got to keep going. The solutions we'll come up with, I mean, we'll keep going at it, and in time, we'll get there. So, with density development, I'll let Rick kind of talk about this a little bit. Where with our fixture testers, we had, we talked about back in the 80s and all the way up into, maybe into the late 90s, we were at 100 mil grids. But then when we got into the 2000s, we actually started being able to get a little bit better at that. So why don't you walk us through a timeline a little bit about fixture density or fixture tester densities?
Yeah, so we were just talking about dedicated fixtures. Um, After dedicated fixtures, we started with a 100 mil grid. Universal is a little bit more cost efficient.
Right, that was our
So
single.
then we upgraded. We put more test points in a little square area. Todd mentioned a 100 mil grid. So every 100 mils there was a test point, both in the X and the Y. And then from there we kind of migrated a little bit smaller. We did something called the double density, where we did the X and Y on 100 mils and then put a test point in the middle and called that kind of double density. And then now we have 50 mil, so the spacing in the X and Y is 50 mil. And then from there it progressed smaller down, like there's 40 mils, there's 35 mils, uh, 24 mils, and I think 22 mils or 23 mils, all trying to get more test points in the little square inch area or a little square area because the boards got smaller. So as the boards got smaller, we had to translate from the PCB to the universal grid tester to try and utilize the grid. We needed more points, test points per square inch in order to accommodate it. And we got down to about, right now, we sold some machines that are 22 mils or 12 density is what we call it. But anything after that at this time, we're going down to a dedicated fixture where you're wiring it in directly to the test point on the PCB. So it's evolved a lot, Todd. If you think about, we were at 100 mils. Basically, this was in the 90s, and now we're down to less than a quarter of that.
Right. I mean, it's an astonishing growth curve, or following the technology curve, I should say, because now, like Rick said, with the commercial stuff that we're doing, that's being done over in Asia, I mean, we're talking wire technology that's down, you know, depending on who you are. I don't have a lot of up on top, but I mean, we're getting down to human hair size of test pins and wires to accommodate some of this. The designs keep getting smaller, and the design guys can do it, but they got to remember that design for manufacturing. If they get too far ahead of the curve, we start getting in trouble, and that's one of the challenges that's going on here in the North Americas and Europe, because to be honest, we're behind in a lot of places of that curve to be able to handle that technology. So, when we talk about the older fixture testers, even though they do have a niche still in certain markets, some of the newer technologies require some higher density equipment, and some of these, and with higher, should I say, with the commercial volumes, automation is another key. So we talk about automation. We have large platform equipment out there that we can take care of these higher density. Some of these are going to be wired, like Rick was talking about. So some of these, Rick, why don't you kind of give me a little bit more of the information that you know on these higher density machines and the cameras and the automatic alignments and things?
Certainly, Todd, certainly. So as the boards got smaller, we adopted different types of universal fixtures. Its fixture technology changed depending on what kind of package you're looking for. You can get a quad density machine, for example, that has CCD cameras. They capture the fiducials on the PCB and then move the PCB to fixture tooling pins around to accommodate any kind of manufacturing shift by piece by piece. There's boards out there. If we talk about flip chip ones that are designed, they basically move the fixture to the board and step the board around the um, single image at a time, because the fixtures are very costly. If you're talking about a 20 micron fixture, it's going to have a price of about $8 to $12 per test point, depending on the whole number of test points. But you take that whole thing on a shuttle and step it through the machine, one image at a time, to save cost and money. It's still more efficient than doing on flying probe when you get to higher volume. So they come in different sizes, different densities, different step automation types. Some of them have arms, some of them have shuttle solutions. There's a wide range of different things, but the biggest thing is to meet whatever the demand is of the manufacturer.
I totally agree. And then we start talking about what our solutions are out there for manufacturing. A lot of it has to do with changing of the mindsets, I think, here to compete with the offshore markets. Uh, Promoting and lobbying for the onshoring of the lost revenue is a big solution for the future. Like you mentioned earlier, the CHIP Act that the U.S. has got going, increase inventory of critical micro and nanoelectronic parts, and that goes as well for the Canadian market and Europe as well. Solutions that our North American people need to reevaluate their manufacturing capability for the advanced technology. I mean, North America and Europe, we kind of missed the transition and we lag behind that technology curve a little bit. Not to be mean to anybody, but the facts are the facts. You just look at where the commercial work went. You have any more to add on the manufacturing side, challenges or solutions for the future?
No, I think we pretty much got it covered. I think, like you mentioned, the CHIP Act. There's other organizations out there that are mainly dedicated to bringing back the higher end manufacturing to the North American and European markets, because we kind of need this technology not to be centralized in one area, as we found out from COVID. So, any equipment manufacturers and process manufacturer specialists, they know what needs to be done. They maybe not have the total solution for the ultra HD electronics, but when we have the microvia process, we see some people out there stacking multiple microvias on top of each other to make a whole structure. We see some companies out there that are making smaller trace widths and spacing, but doing it by plating up rather than being subtractive and subtracting copper away. So all this is playing a role. Each manufacturer or each solution is coming out, and it's making progress. And progress is what we need, Todd.
Absolutely. And one of the things you mentioned earlier on the reevaluating or manufacturing capability, you mentioned, your 2000s, early 2000s, we had hundreds and hundreds and hundreds of board shops in the North Americas, and it's gotten down to, a handful of larger ones because some of the smaller ones either got acquired by the bigger ones for one reason or another, or, it got too costly to advance or stay up with the technology curve that required too much capital investment and was just too hard to work with. So that's one of the reasons why we're seeing, the loss of manufacturing shops. In electrical test, solutions for the future, we also need to reevaluate equipment used in the North American and Europe markets to align better with these nano and micro requirements. And that's, we just talked about, testers and such, and even the flying probers. I mean, there's no question the flying probers can do it. They can get down into those tighter spacings, but the problem is the volume. So unless, you want a fleet of 20 or 30 flying probes to try to stay up with the volume, which is not cost effective either with automation even. And, you have to remember that some of these really high reliability markets, aerospace, medical, and stuff like that, flying probe might not even be the option at all. They may require the parametric test.
Yeah,
So we
Todd,
need,
I
go
even
ahead.
heard around the market that some people are thinking about putting silicone inside the PCB itself. So burying a piece of silicone inside the PCB, one of the layers, and wire bonding to the traces inside the board.
I don't see that as being out of the realm of possibility. I don't see why they couldn't put a cavity and put a microprocessor in the board and wire bond to it. I totally see that coming in the future.
Yeah, as long as we could manage it thermally, it would work out not bad.
Yeah, that's it. It's the heat dissipation problem, right? So moving forward, we're micro and upcoming nanoelectronics are the wave of the future, and that they're here to stay. So we got to take a bite out of that and adapt and move forward. North American and Europe markets, we do have to evolve to challenge the Asia manufacturers. They've had a jump on us for 20 years, and right now we need to get some of that commercial work back. I mean, we're not going to probably get it all back, but we could definitely get some of that commercial work back if we can compete both with technology and monetarily. We got to change the mindset from quick money prototyping and return to good margin consumer volume. And what I mean by that is, just like I had just said, we need to think about bringing in the higher volume rather than swinging for the fence on the prototypes. You can actually make money on the volume too because you got less setup time, less setups, you run the lines a lot longer, and you stabilize your quality in the process. That's one of the main things that commercial shops way back in the day had outstanding quality because they'd fine tune their lines and they'd run thousands and thousands of boards, and your defect rate was extremely low, and that's always been a challenge for the markets. When you have high turnover on setups, you run into quality problems and such like that. We want to automate those repetitive tasks and reduce your labor health costs and use your best minds where they're needed more rather than doing mundane tasks and hurting themselves. And we want to push ahead of the technology and not let the technology pass us.
Yeah,
So
Todd.
that's one of my moving forwards. Do you have any more?
And Todd, the interesting part is how is AI going to fit into all this? Because from the way I see it, there is some process controls that would benefit a lot from having artificial intelligence in there with a lot more sensors in various processes throughout the plants. It doesn't have to just be PCB; it could be just any plant itself. But the market is evolving, and you see it across even in PCB board design. You see a lot of companies out there developing AI for PCB design. I don't know what's going to come out of that. You get more thinking power in this process, and maybe they come up with some slicker designs for a printed circuit board
I
rather
think
than.
that's.
Go ahead,
Go
Todd.
ahead. I think it's actually a pretty strong moving forward, the AI technology and circuit boards, and you see it actually in other industries where they're doing it in graphic design and a lot of other modeling and prototyping for building and street layouts and community, what do they call it, urban growth and all that. They do all kinds of modeling with this AI stuff that I've seen, and so I see that in our industry as well. It's instead of redefining or redoing these tasks all the time, you let some artificial intelligence make real educated guesses on some of the things that you're doing. I agree.
Yeah, it's very exciting. The path forward is very exciting for the PCB industry.
It
I'm
is pretty.
excited too.
Yeah, it's pretty excited to be in this right now, especially when we're way back in the beginning when circuit boards were still pin and hole and double sided, and some were even hand lay up and things like that to where we are today. I mean, the advancements are amazing. Just like our parents and grandparents went from the horse and buggy to seeing Apollo, land on the moon in their lifetime. And I think we've even accelerated faster than that. I think that wraps it up for us, folks. Once again, thank you for stopping by and having a listen to our latest podcast. I know we've been a little tardy here. We're trying to get ourselves back on track and keep some information coming out. Any closing comments for you, Rick?
Todd, just keep pushing forward. There's a lot out there. There's a lot of technology changes. I know we're getting older. Everyone's getting older, but we need to educate some younger forces to maintain this industry and push us forward into whatever the next beginning will be for the printed circuit board.
Absolutely, and I agree. And that's what we're here for. I mean, we supply services to the PCB industry and equipment as well, but we also are a knowledge base as well. So if you want to have some questions, you can contact us at info@guardian.com, and you can visit our website at www.guardian.com. We have a nice knowledge base of a lot of things there regarding electrical tests, and we have our equipment lines that you can look at, and of course you can always get in touch with us and ask us personally if you've got questions. So on behalf of Rick Murrah and myself, Todd Coleman of the Guardian Group, we really enjoyed having you here, and we hope to see you next time on another Guardian podcast.